Okay, so we've talked about the center of the data. We've talked about how spread out it is, range, standard deviation. Now we're going to talk about position within that distribution. So the first type of positioning is quartiles. What do you think that means we're going to do with the data? Quarter it. We're going to divide the data into 4 equal parts. Oh my gosh. Divide the data into 4 equal parts. This is the most used way to separate the data. But if you wanted to dig deeper, we could do different fractiles. That's just dividing the data into equal parts. So quartiles would be 4 equal parts into equal parts. Percentiles would be 100 equal parts. You divide it up into percents, 1%, 2%, yeah. Dividing up the data. So you could divide it by tenths, you could divide it in hundredths, you could divide however you want to divide it. 4 is most common. It's easy. Now, vocabulary. We talked about the range before. I should have added this in. What was the range? Max minus min. Now, if we divide into quartiles, what we can have is something abbreviated as IQR. That stands for interquartile range. So instead of the max minus the min, interquartile range is the middle 50% of the data. So it is the third quartile minus the first quartile. So it's not max minus min, but you're zooming in a little bit closer. And we'll see that in action on one of the examples. So instead of max minus min, you're zooming in one step further and getting closer to the middle. Now, you probably remember box and whisker plots. Maybe not. Box and whisker plots look like this. There's a box with whiskers. We're going to learn how to make those today. And what a box and whisker plot does is it's a visual display of the 5-number summary. Well, you may ask yourself, what is the 5-number summary? Well, the 5-number summary is the minimum value, the first quartile, the median, which would technically be my second quartile because it's in the middle, third quartile, and the max. So this is abbreviated a lot of times as Q1. First quartile, Q1. Third quartile would be Q3. So just some notation. Now, standard score, we'll probably stop and do that one tomorrow. But standard score is, hold on, I want to make sure I get my wording right on this one because I said it weird the other day. This represents the number of standard deviations a value is from the mean. So it has to do with mean and standard deviation. So that's why it's okay to move that one to tomorrow. Everything else is going to deal with this 5-number summary. We're going to deal with quartiles. Min, first quartile, median, third quartile, max. We're going to be using this 5-number summary a lot. So let's go ahead and jump into an example. We're going to talk about quartiles. So our first step to find quartiles is going to be to list the data in order. Now, the easiest thing to do is to find the median. You're going to find the middle of your data. The median splits your data in half. You got 1/2 lower, 1/2 bigger. So to find your quartiles, you'll next split each half in half. If you split a half in half, now you got quarters. Quarter, 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 quarter. So we're going to do the first one by hand. I'll also show you how to use the calculator, but we'll do the first one by hand. It's just 15 test scores, not too hard. Our first step is to write them in order. So what's the smallest? 65? Yeah, 65, I think. Then 67. I don't see a 68. So 69. 70. 71. 72. Nope, I don't see a 72. 73. 74. 75. 76. 57. Oh, there's 2 78s. So remember, we do have to list each value. Very important. And then we've got 80, 81, and 97. So we have 15 values. Now, to find the median, you can either do it the old-fashioned way of counting like all the way in, or think about it. 15, what's half of 15? 7.5. So if I count in 7 each way, I'm going to meet the middle. So if I count in 7 each way, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. The middle number is my median. Now that splits my data in half. I've got 7 on each side of it. So we need to find the middle of each side. So what's the middle of the lower side? There's 7 values. So 70 would be my Q1. That's my first quartile. Technically, my median would be Q2, second quartile, 50%. And then the Q3, 78. So just a reminder of what this is doing. It's dividing me into quarters. So 25% is in this group. 25% in this group. 25% in that group. And 25% here. So the way we would interpret this is that we could say 25% of the scores I can't write are below 25% of the scores are below what value? 50% of the scores are below 75. 75% of the scores are below what value? 78. Could I even go the other way and say 25% are above 78? 75% are above a 70. We even could say there's 50% between 70 and 78 because that's the middle 50%. Now let's also do this using technology. So in the NumWorks calculator, we're going to go to the statistics app like we always do. And we're going to put our data in. So it's in the statistics app. Pull mine up. So full screen. So just a reminder, we're going to go to the statistics app. If you have data in there, you can press Shift Clear and it will clear it out. But we're going to type in each data value. Once you have your data values, where do you think we go to find the calculations? Stats. Okay, so I'm going to go to stats, and I'm going to click OK. It tells me my minimum was a 65. Was it? Okay. First quartile Q1, did we get a 70? Median, 75. Q3, 78. Maximum, 97. It gives me all of those good values. Now, what we're going to do on the next page is we're going to use those 5 values, the minimum, first quartile, median. We're going to use those to make a box and whisker plot. But first, let's talk about this range and interquartile range a little bit more. So, whoops, let me get to that screen. So I'm going to write down those values off to the side because we're going to need them. The min was 65. Q1 was 70. Median was 75. Q3 was 78. And the max is 97. This grouping is called the 5-number summary. Because it has 5 numbers. It's the 5-number summary, and it's really important. Now, I wish I had added this in. I want to find the range, and then we'll find this thing called IQR. So range was my max minus my min. What would I get when I take the max minus the min? 97 minus 65, 32. There's a difference between the 32 points difference between the highest grade and the lowest grade. But does that tell you really much about what's going on? Not really. The IQR gets kind of zooms in a little bit. IQR is found by taking Q3 minus Q1. So if we find the IQR for this data, we're going to take Q3, 78, minus Q1, 70, and we get an 8. What this tells me is that the middle 50% of the data varies by 8 points. 50% of the scores, there's only a difference of 8 points. That tells me a lot more than there's 30 points between the highest and the lowest. Now we can also see this IQR and see our range when we go to a box and whisker plot. So we need to plot our data. Let me see something. 4, 5, 6, 7, 8, 9. I think we can count by twos and be okay. So let's go 60. Odds would be okay. 63, 65, 67, 69, 71, 73, 75, 77, 79, 81, 83, 85, 87, 89, 91, 93, 597. Notice I went by odds because my minimum and my maximum were odds. I could have gone even if I wanted to. But I just counted by two, 63, 65, 67, 69. So a box and whisker plot, the whiskers go out to my min and my max. So I'm going to put a line at my minimum value, 65. Here's my min. And the max gets a line. Now the box for box and whiskers is around my IQR. It's around the Q1 to Q3. So it's giving me that inner quartile range. So I'm going to put a line at Q1, 70. I'm going to put a line at Q3. And I'm going to make a box around the Q1 and Q3. Now, these are my whiskers going to the min and the max. That's how we make a box and whisker plot. Now, I also like to draw in the median because I'm supposed to be seeing all 5 numbers. So the median is at 75. It's right here. Now, looking at this picture, notice that the majority of the values are hanging out right here. And then there's a long stretch to the max. What does that tell you about the data? There might be an outlier. And is it symmetrical? Skewed right. So you can see all those same things on here. If this whisker had been shorter, like let's say right there, it would have been symmetrical. The whiskers are the same length. So you can see a lot of it from this data. Oh, I forgot to say this was the median. But y'all said that 97 might be an outlier. There is a test for outliers. The test for outliers is that anything past 1.5 times the IQR from Q1 and Q3. Those are outliers. So we're going to have a lower boundary and an upper boundary. The lower boundary is 1.5 times the IQR below Q1. So that'd be Q1 minus 1.5 times the IQR. The upper boundary would be above Q3. So it's Q3 plus 1.5 times the IQR. So our Q1 was 70 minus 1.5. What was our IQR? 8. So 70 minus 1.5. Whoops, I gotta go to the home screen. I got 58. Okay, 58. So anything below 58 would be an outlier. That's my lower boundary.
You can see that on the calculator, right?
No. So we need to know this formula. Upper boundary, I'm going to take my Q3 and add 1.5 times the IQR. And I got 90. So above 90 is an outlier. So good numbers are going to be between 58 and 90. Did we have anything below 58? Did we have a number above 90? Which one? 97 is an outlier. It's past that boundary. So that's how we find whether something's an outlier. Now, before we go on to the next example, I do want to show you that if I go to graph, remember this will make a histogram. What's the next option? If I go here, it starts off on the whisker here, it says that 65. Now on this one, look, what did it do here with the, why is there a dot way out there? First quartile 70. It says upper whiskers at 81. And the maximum is 97. Why did it put a dot way out there instead of extending the whisker? Because it's the outlier. So this calculator, this time it moved and set the outlier like that. Now, you can actually draw it both ways, whether you want it to display outliers or not. If I do that and then go back, so it included the outlier on that one. It can show you that it's an outlier, but it's not always going to do that. All right, let's do one example here. The following table represents the number of students absent in middle school. Make a box plot and identify any outliers. If you want to do it by hand, feel free. 5-number summary. I would do it in the calculator. And we need to find our min, Q1, median, Q3, and the maximum. That's going to give me my numbers to make my box and whisker plots. Sure I didn't type too fast. Is this what y'all got? 41 for the minimum, 45. So I'm going to write those down on my sheet. Minimum was 41. Q1 is 45. Median is 51, 59, and 100. So I'm going to kind of, let's see, 40 to 100. I don't know, 45, 50, 55, 60. Does that work? 65, 70, 75, 80. Maybe it would have worked if I had thought about it ahead of time. 85. Gosh, I should have started smaller. 40, 45, 50, 55. That might work better. 60, 65, 70. It's better when there's a grid already drawn for you. I'm going to do that next year. Okay, 100. So we put our whiskers at the min and the max. So 41 to 100. The box goes around your quartiles. So the box is going to go around the quartiles. 45 to 59. So this is Q1, Q3. In the middle of the box is going to go the median. Would you say this is symmetrical? No. What does it look like? Skewed right. Could there possibly be an outlier? Let's find out. So we first need to find the IQR, which is just Q3 minus Q1. It's how far apart that box is. So 59 minus 45 is 14. Then we need to find our lower boundary and our upper. The lower boundary is going to be Q1 minus 1.5 times the IQR. Upper boundary is Q3 plus 1.5 times the IQR. And just like the professor I had in college told me, I have no idea why it's 1.5. Somebody came up with it and it stuck. I don't know. 45 minus 1.5 times 14. Did anybody already figure that out? Oh, the top one is 80? Okay. Right, that can't be the bottom one. 80. The bottom one is 24. So this is the range we should stay between, 24 to 80. Are there any of those values that are below 24 or above 80? So 100 is an outlier. Okay, we'll stop there and finish up on tomorrow because I know some of you need to go print.